Hello, and welcome to a webinar on 3D printing applications. My name is Andy Dio with Saratech. I'm your host today. Also on this webinar with me is Terrence Smith, our Ceratec Solutions Consultant, and our special guest, Ross Adams, Markforged Application Engineer. In the next 30 minutes or so, I'll spend some time introducing you to Ceratec and discuss the evolution of manufacturing. Terrence will also cover Markforged 3D printing platforms and applications, and also share some case studies of customers who save serious time and money by deploying Markforged technology in their business. We'll also be sharing with you ideas on where to look in your business for 3D printing opportunities. Now, a little bit about our company. Saratech is an engineering organization with expertise in product development improvement and product lifecycle management systems. We provide engineering services, software, and additive manufacturing technologies to help customers solve product development challenges. We're headquartered in Southern California in Mission Viejo, but we have sales and technical resources across the US. Most of us are working virtually, so we're very used to the current working climate. Our company understands product development. From design to manufacturing to data management, we not only provide customers with leading edge technology, we actually use the technologies that we sell for internal product development and for customer support. Over 50% of our team members are engineers or have advanced degrees. Our core DNA at Ceratec is engineering. Our customers range from small, medium-sized companies to large, multinational corporations spanning across all major industries. I also wanted to point out that Ceratec is a partner of both Markforged and Siemens. And why is that important? Well, the combination of PLM software from Siemens and 3D printing technology from Markforged is second to none. We have the expertise and tools to help you accomplish your business objectives. As a matter of fact, just last year, Siemens and Markforged announced a strategic partnership with the goal to further the industrialization of additive manufacturing. So, two really good companies to work with, and we're proud to be partner with both of them. So speaking of manufacturing, we are all here today for the same reason, right? To stay current about advances in technology that can make us more efficient, make our jobs easier, or provide a competitive advantage in a tough market. Manufacturing is at its core fueled by a drive for greater and greater efficiency, and it never stops changing. It's what keeps our lives interesting, but also make it a challenge to stay competitive, and we all know that in this climate. Sometimes these changes produce incremental results. Think about increases in electric motor efficiency or sensor accuracy. But on occasion, technologies produce massive waves throughout the manufacturing landscape and fundamentally change things. So manufacturing technology has changed by leaps and bounds in the last 100, even the last 50 years. We've gone from the assembly line to lean production cells, from hand tools to CNC machine centers, and we're currently figuring out where and how automation fits in the mix. We've come a long way in the last century. But at the same time, there's a lot that hasn't changed either, right? So we still cast metal into molds to avoid manufacturing downtime. We still have to carry extensive back libraries of tooling and replacement parts. Minimum order quantities are still high, and lead times are long, especially on low volume parts like tooling and fixtures. Tried and true manufacturing methods are reliable, but they're holding us back from greater gains in speed and efficiency. One thing that's always changing are the pressures manufacturers are under to deliver. As technology improves, so do the demands of internal and external customers, leading to ever-decreasing cost goals, right? Every company is looking to cut costs and improve efficiency. And you always want to move faster and faster in bringing new products to market. You all probably recognize these two cars. On the left is a Tesla Model S, and on the right is a Ford Model T. The two people behind the development of these cars probably need no introduction, Elon Musk and Henry Ford. So what do these two individuals have in common? They both brought disruptive technology into the automotive market. They're innovators, they're game changers, and no doubt geniuses, and will forever be business icons. But you know what's another key similarity between these two individuals? Despite 100 years of technological development, time to market is no faster for Tesla than it was for Ford. Just think about that for a second. It's been 100 years, and it still takes 5 years to build and ship a car. Why is that? Well, first of all, cars are complicated, right? They're made up of thousands of parts. There's a lot of things that are involved in building and manufacturing a car. But our approach to producing parts have not changed much. There's a saying, the more things change, the more they stay the same. But with so much technology out there, it's difficult to figure out what's right to do. What is the right technology for your business? Which brings us to the new technology that we came here today to talk about, 3D printing. So there's been a lot of hype around 3D printing in the last decade. And it's generally focused on using 3D printer in such a wide range of applications that it's become tough as a manufacturer to know where to start. And hopefully this webinar will help you toward that. What's worse, much of the hype for 3D printing has focused on pipe dream applications that are in no way achievable in the next few years. While it's important to be aware of future technology, you're here today to learn about how you can make an impact on your business now, today. We're going to make it easy to start your journey with 3D printing and show you some of the most high impact applications to focus on when you're evaluating 3D printing for your work. So before we get started, I just want to take a quick poll in the audience. It only take about 30 seconds or so. I'm going to launch it now and share the results with the rest of the audience. All right, so here's our poll result. 22% of you are very happy with the 3D printing technology that you have today. Almost 40% are using 3D printing, but not sure that you're getting the most out of it. 6% of you want to employ 3D printing technology, but unsure about its application. And about a third of you are just starting to learn about 3D printing. Great feedback. Thanks, everybody. So let's talk about Markforged 3D printing technologies. At this point, I'm going to pass a presentation to talk about what Markforged has to offer. Terrence, to you.
Andy, thank you very much for the introduction. Everybody, I definitely appreciate your time on this Wednesday afternoon, and we hope that the content to follow includes an overview of the technology and a few case studies that should be relevant. Just real quickly, I've got 20 years of experience on the West Coast in design engineering simulation, physical test, and 3D printing technologies. I've been successful in having companies adopt topology optimization that helps shorten design cycles and decrease mass. I also have worked with thermoplastics and thermal sets with regards to improving their performance by adding fibers. And then finally, I've helped companies with the adoption and use of metal and polymer printers to help implement these unique benefits into their value streams. Everything I just described is why I'm so excited about the Markforged technology, and I think we'll be able to see that in some of the coming examples. So let's talk about the Markforged technology. Here you see that we have really looked at hundreds of 3D printing cases, and it's clear that there's a strong movement towards additive manufacturing. Markforged has put together a report of these use cases. You can download them through our go-to meeting or through a webinar following this presentation. Read the report and meet the manufacturer's capitalization of 3D printing to find out how and why companies are using this in their workflow. From automotive to aerospace to electronics to manufacturing, these modern manufacturings are already part of the movement. Each of these practical 3D applications form Markforged customers, and Saratech can help you through any hurdles with design, applications, and engineering of these product lines. Another very unique thing about Markforged is that it's one of the only companies that offer a full platform for 3D printing. What does that mean? They have various machines that we will talk about today that allow you to print unique plastics, plastics with fiber, and metal parts. They also have an enterprise software tool that comes with the package that allows you to be successful in placing, automating, or optimizing the print direction, the print speeds, and the design that's put into this. And then finally, Markforged has a list of variable materials along with fibers that can be filled through chopped form or continuous fiber. And again, we're going to show some of those examples as well. So it's really a one-stop shop in printing. When we talk about a complete solution with the Markforged technology, you basically need to start with a design. You need to start with some sort of CAD file. You'll be able to upload that technology into their patented software called Eiger. It ties the hardware, your designs into the ecosystem and directly communicates with the machine to allow for it to print using slicing and different configurations. Security is a top priority for Markforged. So there is only one 3D company that has achieved ISO 27001 certification, and that is the Markforged company. Eiger, again, is a software that allows you to upload the file, configure it, slice it, place it on the build platform, and send to the Markforged printer. One of the things that excites me is what I'm going to simply refer to as a hybrid product development process. So as an engineer, we see a lot of tools that have always been made out of cast parts or iron or steel, and very reasonably because that's what they needed to do in the history due to thermal temperatures or wear and tear. But what we've been successful in is a hybrid mix of polymers with or without fibers, and then using inserts or a secondary type metal or even polymer to interface with a gripping of a part, a wear and tear on a machine, etc. And so some of the different materials, and we can go into much more detail in a different dialogue, but some of the plastics that Markforged supports is onyx, which is a blend of nylon and chopped fibers. Could be carbon, could be other fibers. They have a nylon, and then finally they have some vehicle and interior polymers on the onyx side that help with UV and other environmental conditions. On the fiber side, carbon fiber is available. Kevlar is also a very popular choice. On the lower cost scale, fiberglass and high strength fiberglass offer a lot of economical values to your printing process. When it comes to metal in Markforged, there's 17 pH, 4 PHS. There's several different tool steels. We're one of the companies that print Inconel and 625, and we definitely are unique with regards to the ability to print copper. In case you're not familiar with the Markforged composite printing process, basically we're using continuous filament fabrication process to lay down continuous strands of fiber throughout the part. This gives you high strength composite effects once it's mixed with the onyx. And this allows you to achieve material properties through stress, strain, and ultimate values on the level of aluminum 6061. To take advantage of this process, you'll still want to design your part in CAD using traditional methods. You can use topology optimization. You should absolutely look at part reduction capabilities. So you don't want to just print the part that you've always constructed. Let's, if possible, look at the design process and use some new modern benefits that help you and your company. You can learn and utilize Markforged machines with both metal and composites by downloading the design guide. It is available to you on the Markforged website, also the Saratech website. The design guide is a great way for you to look at and determine how your existing part could be modified to better support the printing process. The guide was developed to provide comprehensive foundations. And finally, our team and the Markforged team is here to help you with part identification and any questions you may have to get to the next level. Let's use this in a form of a case study. So Stanley Infrastructure, I think we're all aware of Stanley with regards to home tools, drills, saws, but their industrial division is a very heavy industry tool manufacturer, and they build this handheld hydraulic tool that can be handheld or mounted to heavy equipment and is used to allow to put in posts or signage or different type things. So Stanley's infrastructure to build handheld products is a very important characteristic. Their infrastructure, their business is what they make tools, and they're expected to last and support for decades. But there are also low-level volumes of hundreds of replacement parts per year. So whether it's an initial allotment or a replacement part, there are always ways to improve, bring down costs, and impact customer satisfaction. With this case example, we're looking at the P45 post driver. So Stanley is consistently looking to innovate and improve their process, and so they worked with Markforged to help develop a more economical solution for building replacement parts for this hydraulic post driver. This device is used for driving in road signs and into the ground and experiences a lot of vibration and shock. A part of this driver also tends to fail simply because of the traditional and earlier design process. So the part was cast. It was a multi-piece component that had an exterior sleeve that was bolted, and there were internal mechanisms of bearings that helped activate the trigger and apply the pressure in a timely manner. Because this component was multiple parts and due to the environment, these things could separate slightly. There could be leaking and eventually just the breakdown from the wear and tear to being a multi-part component. So the next slide. Customers come to us quite a bit because they have experience, they have testing, they have all these parts that they've made successfully for years, and they'll ask, can we print this? The answer is yes, probably. There may be some slight changes, but your traditional methods, you've been successful for so many years, it may not make financial sense to print it. So what we like to do is ask the question, is there room for improvement? With this part that's been in existence, is it impressive to remove mass? Is it better to reduce the amount of components, hence reducing the amount of risk for leakage or failure, or the amount of physical labor to assemble during production, but also fix or replace while in the field? So Stanley redesigned this part with the assembly to optimize for 3D printing using Markforged technology, taking it from the assembled 4 parts to a single part. You'll notice that they did change the hole pattern from a circle to a hexagon. This allowed them to avoid using supports and avoid some post-processing to make the costs even more attractive to switching to a 3D part. Stanley's life cycle for testing includes a robot, which activates the switch for hundreds of cycles, and the 3D printed part passed with flying colors. I think this metric is absolutely impressive. So on production runs, at the beginning of this product cycle, we're printing hundreds of these things. We're able to reduce the part cost by over 42%, and we're able to get this to market in 75% faster than the traditional methods. You can imagine with casting a part, it's going to take time for tooling, it's going to take time for shipping. Casting the parts, finishing the parts, assembling the parts all takes time. So with these parts coming off as one monolithic structure, you're definitely impacting the cost and the lead time. If we look at this with regards to service and replacement, it's even more impressive. Instead of having hundreds of these things in bins that we have to ship out to a field when it breaks, we should be able to either provide the construction company, Stanley, or service providers these drawings and part files so that they can print these parts on demand. So I believe this part printed in less than 9 hours. So if a part breaks, there's a service call. We should be able to have a finished part the next day on the field being installed and impacting that installation of signage and posts.
Great, thanks. Thanks, Terrence, for that example. So we've shown you how 3D printing is changing manufacturing, right? The technology behind Markforged 3D printing stand a success story. But when you go back to work after today's presentation, you might be wondering how 3D printing could help you, right? So on the survey earlier, quite a few of you say that, hey, you use 3D printing today, but you're not sure that you're getting the most out of it. So let's show you how to find good applications around your business. So there's 3 main perspectives to look at your operation for 3D printing applications. First is economic and cost-based drivers. Second is common manufacturing applications that continue to resurface at plant after plant. And third, you can look at common materials often used in tooling and fixtures. We're going to go over those things. So let's start with the economic drivers. When it comes to actually reducing these costs, some of the biggest opportunities that we see are in reducing unplanned downtime. No one wants that, right? Unplanned downtime, making it more efficient to change over and making it efficient to change over manufacturing line and reducing the cost and efforts of upgrading existing machinery with new sensors and safety equipment. And finally, Markforged is a great solution to what I call cardboard engineering. I know that's not a particular technical term. I'm not a technical guy, but I think you'll recognize what I'm talking about when we get to it. So let's talk about unplanned downtime. One of the biggest cost reduction opportunities is to reduce unplanned downtime. So let's talk about what that is. It's sometimes known by a few different terms, but basically we're talking about production stoppages that you didn't plan on having, whether due to equipment failure or some kind of jam in your line. It can come from a number of different sources, but the bottom line here is unplanned downtime is lost productivity and it costs a lot of money. So 3D printing allows you to make replacement part quickly and more cost effective, as a prime example with the Stanley case that Terrence just talked about earlier. There's often a lot of opportunity to print components which upgrade or repair an aging machinery. These could be brackets and mounts for sensors which monitor your processes and improve your yield and efficiency. And they can also be parts to mount modern safety equipment and keep older machines compliant with modern regulations, as you can see where the arrow pointing right now, the red arrow, that's a mount for that sensor. And finally, a really common phenomenon we see in manufacturing plants is something I like to call cardboard or duct tape engineering. These are generally some sort of temporary fix that wasn't documented and was put in place to hit an upcoming production deadline, but never got replaced with a permanent solution. It's funny how like temporary fix most oftentimes becomes a permanent solution, isn't it? So with 3D printing, you now have a better way to do this. Despite vast differences in types of products being made, we find a ton of applications that are common across manufacturing fields, whether you're making tractors or night vision goggles. So let's talk about some of those. I'm going to send the presentation back to Terrence to talk about a couple more case studies that we found that may help give you some insight. So the first case study is about end of arm tooling. Terrence?
Yes, thank you, Andy. I appreciate that. These case studies are available on our go-to site that you'll see. It's also available on our website, so please feel free to dive into a lot more details than I'm going to cover simply because of the time constraint that we have. The Dixon Valve Company is a 100-year-old manufacturer of hose couplings and fluid transfer accessories. They worked with Markforged on reviewing some of their parts and trying to find the best solutions to add the technology in an ROI situation. Specifically, Dixon was interested in automating the technologies which assist and amplify the productivity of their workforce. Dixon employees, for example, work closely with CNC machines intended for industrial robotics, which was offering a safe and more ergonomic alternative to loads applied to this actuator. In this example, you will see that they came up with printed custom fingers that were inserted at the end of the arms for robotic cells. The end of the arm tooling was a perfect application for 3D printing. It allowed for some creativity. It included some unique shapes to allow for installation. And finally, it was very successful in being able to grip and perform the tasks that it was intended for in some low volume production situations. So this was perfectly suited for Markforged and the 3D printing process. When you look at the metrics, again, being able to decrease time and save costs, those are things that help impact the ROI. So Dixon was very impressed with the ability to, instead of taking a month, in less than a week, be able to put and install these things and get things back up and running, not only for them, but also for their customer base. Finally, the cost savings over the CNC process, the raw materials. When you look at all the advantages of additive manufacturing, the Markforged technology saved them about 82% and obviously paid for a machine in pretty record time, almost a month and a half. The next and final case study is with regards to CMM nests. Again, just want to give you some visual products to show you how the Markforged technology can impact this. So J.J. Churchill is a long-standing leader in precision aerospace and manufacturing. They produce turbine blades for a range of OEMs. The turbine blades do take a long time to manufacture due to the expensive process. And to maintain their market leadership, they're always looking at innovative engineering, design, software, or manufacturing methods to impact tooling. Here you see inside one of their chambers, they meticulously inspect every single turbine blade to make sure that the CMM values ensure safety and quality. The blades are held in place in this fixture and device and need to be repeatedly located to allow for measurement without damage. You can see in this image that these printed parts are available to conform to the geometry of the root of the turbine blade. Each one may have a different pitch or yaw, and 3D printing is obviously an attractive ability to go after that. What J. Churchill found was they were able to decrease their lead time from traditional methods from 10 days down to 3 days, and have a drastic impact in cost in labor and materials by decreasing it by almost 80%.
Fantastic. Thank you for those case studies, Terrence. As you can see, there's tremendous savings in time and money when 3D printing applications are employed the right way in your organization. So talking about the other ways, the third and final way to search for ways to save with 3D printing is the most general way, that's to look for applications based on the type of materials that are using in-house today. Specifically, we're going to look for materials often used in tooling and fixturing applications. So as you've seen, we generally see that Markforged can replace parts traditionally made from both some common engineering metals and plastic. The first thing to note is that materials marked with an asterisk here are materials which can often be replaced by 3D printing, a 3D printing part that incorporates off-the-shelf inserts made from the material in question. This isn't always the case, but many times an application demands the specific material property of one of these materials in a surface region alone, but the rest of the part can be composed of a different material. These applications are naturally suited for 3D printing because you can easily design and print a geometry which incorporates an off-the-shelf part for far lower cost than traditionally manufacturing the original part. So fixtures and cradles like this are very typical in an industrial manufacturing environment. And you'll often find that nylon, UHMW, and Delrin are used in these applications for their non-marring and impact-resistant properties. Markforged part can easily stand up to these environments, and there's no penalty for fixture complexity. Unlike machining, 3D printing time doesn't really depend on part complexity, just the volume of the part. In fact, the more complex a fixture, the more attractive it can be to 3D print. So we talked about manufacturing innovation, Markforged 3D printing technologies and applications. Terrence showed you 3 case studies of customers benefiting from 3D printing technology. Think about how you will use 3D printing in your business. So we have a couple questions that came in. One question came in from Michael. What equivalent grade of aluminum can you print in? Ross, can you address that?
Yeah, as far as like equivalents to aluminum, well, if you're looking on the composite side of things, if it's aluminum because it needs to be strong, then onyx reinforced with continuous carbon fibers, certainly the material selection that's suited for replacement of that application. If it's aluminum because it has to, involve some heat and, applications that can't be made out of a plastic or a composite, that'd probably point to one of our metals capable on the Metal X system. We don't print in aluminum for a variety of reasons, but as far as suitable replacements goes, if it's corrosion resistance, then 17.4 or Inconel 625 would likely be your candidate to replace aluminum in that case. And with the infill that the parts are lightweighted with, you can achieve similar weight properties of aluminum while using steel, while exceeding the strength of aluminum as well. We also have a variety of tool steels, A2, D2, and H13. And depending on what you're using aluminum for, if it's tooling that has some hardness characteristics, you could probably exceed the characteristics by printing in a tool steel, which has high hardness.
Great, thank you, Ross. We have another question that came in from Marshall. How much post-processing machining is needed on metal printed parts?
So, it's really going to require, it depends on your requirement and what your tolerances that you need to achieve are. If it's a small part, your part off the printer will be much more accurate than large parts. 3D printing typically has a linear tolerance scale where the larger of a part, the more variance in tolerance you will get. So we typically point at around plus or minus 0.5% of the dimension that's required. If it's something that's just like a hole that you need to have a critical diameter on, it's a very easy step to just undersize that hole and drill out the pilot hole to its final size. Much easier than traditional approach of fixturing the block and directing the tool to go to a specific location.
Okay, great. We have another question that came in from Brian. Reading the question, maybe you need a little bit of clarification here, Brian. Brian has a question: how does the durability compare between a metal printed object versus a 3D printed part? I'm a little bit confused on the question because the metal, if you 3D printed a metal object, it is a 3D printed part.
So if the question is posed as how does like a traditional tool steel compare to a 3D printed tool steel, the answer is they're essentially the same. This is just a different process to get you to that end result. But 3D printed H13 tool steel is similar characteristics to a wrought H13. So you can heat treat these, you can weld them, you can machine them. It's just a different way of getting to that process. So in some cases, you might even find that you're able to substitute materials. Maybe you select something that's a little softer for machining characteristics, but now if you can 3D print it at a near net shape, you can substitute for a higher hardness material without the negative consequence of more expensive part due to machine and labor.
Great. Us. Then John had a printed. We'll get in touch with you offline to understand what your requirements are and sample part and yeah, with that. Brian had a follow-up question, Ross. Any of the Markforged machines 3D print hybrid materials?
It's an interesting question. I'd be curious to hear more about the application that you would be utilizing and the materials that you'd like to combine. But the thing is, the system is only able to print one material per part. Reason being is the sintering cycle, which is the third step in the metal 3D printing process, is tuned to the material characteristic. So depending on like the max temperature that we achieve to ensure that the particles of metal sinter together is going to depend on the material. So you wouldn't be able to use two materials inside the same sintering process.
Great, thank you. I think that's all the time we have for questions today. There's some next step that I'd like to challenge you to do. So first download and review the case studies. There's literally 100 of them. So in the handout section of the GoToWebinar, I put the 3 case studies that Terrence has mentioned. I also put the 100 ways document that Markforged has put out, which has some very cool and useful information that you can look at and see how 3D printing is applicable to what you do. The second thing that I want you to do is review your internal processes for 3D printing applications. Can you find any based on the 3 areas that we kind of pointed you to today? And if you need help figuring all that out, feel free to reach out to Saratech. We're here to help you. As I mentioned, we're an engineering company. We've been through this process. We work with a lot of customers. So I guarantee you we'll be able to find a way to help you.
Yeah, if I can expand on that last part, Andy, just briefly. Everyone, thank you for joining us. Each of you come from a different company background. You have different products. I absolutely would invest time to listen and even do a part review with you, and then determine if a next step could include services. But by no means hesitate in contacting us about the adoption of 3D printing.
Great, thanks, Terrence. With that, I thank you for attending our webcast today. Hopefully we presented you with useful information that you can take back with you. My thanks to Terrence and to Ross for being part of this webinar. Don't forget to follow us on social media. Our YouTube channel has a lot of useful information as well. Just make sure you follow us and you'll always get the update. Thank you, everyone, and we'll see you soon on a future webcast.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at ceratec.com/events.